Hi! On previous video we discussed some basic principles of controller library. Now it's time to have some fun with it. As you can see, I have added several devices that form central heating system. We have a heater, circulation pump and radiator valve. Of course, it's really minimalistic comparing to what you can find at real home, but it's still only tutorial, so I don't want to complicate it more than necessary. The point is, we have several devices that are not meant to work in isolation. They are supposed to cooperate according to some algorithm. In this case, their mutual purpose is to keep the temperature in our living room at some specified level. To achieve that, we need to start circulation pump, open radiator valve and start the heater. Later on, we need to adjust valve position as necessary to keep temperature we want. For your information, I have implemented separate controller within living room weather station to simulate temperature changes, but it's irrelevant for this demo, so I won't play with it right now. It's just for you to know what's going on. If you're curious, you can always download the entire system from examples section on project page and check it yourself. Okay, so now we need to create some code that will take care of device orchestration for us. I actually created it already. As it's something more complex this time, I used TypeScript version of blank project to create it. I have split the necessary logic into several files. First I created control panel. We still need to interact with our system, so we need a device in living room where we can adjust desired temperature, start and stop entire system, and probably it would be nice to have some short information on what our system is doing right now. I could create a separate device for that, but as we need only one control panel in this specific case, it's just convenient to do it here. Next I created model. System model provided by controller library is very generic as it needs to be able to cover any possible scenario, so it might be a bit difficult to interact with it directly. So I made my own model specific to my use case and put inside only what I need. Of course, I still need to bind it with system model, so I invoke getSystemModel, create some helper function that will simplify initialization of device models, and create device subscriptions for required devices. For demonstration, I used different methods of finding proper device within system model. For heater, I just look for device with name heater. For pump, I look for device with specific UID. You can always check device UID within system image. It's a JSON file within your local server root directory. I just format it so it would be more readable and search for pump. Yep, here is my pump and here is its UID. For valve I use info fields same as in simple controller example. Finally I need to find proper weather station. We have two weather stations in our smart home, one in living room and the other one in backyard. So I look for device which group is living room and name is weather station. Cool, we have control panel and model. Now we need the actual logic. It sits within controller file. Here we define possible states of our system, some helper methods to figure out if the system is ready, if it should be started at the moment, if it's still necessary to keep heater running, and how to adjust radiator valve. We also create procedure to start the system, stop the system, and how to perform emergency stop. Finally, we have a callback that should be invoked when state of any model component would change, and another one for changes of temperature measured in living room or set on control panel. So here is how it works. Whenever something changes with components availability, we check if system is ready. It's ready when all the components are ready. If so, we set proper state on control panel, and if main switch is on, we start heating. If system is not ready, we either do nothing if it wasn't ready anyway, change the state to not ready if it was ready but not started, or perform emergency stop in any other case, which basically means that we stop everything immediately. To start heating, we first check if it's really a moment to do so. If so, we set proper system state, switch on circulation pump, wait 5 seconds while pump runs up, open radiator valve to desired position, wait another 5 seconds for the flow to stabilize, and finally switch on the heater and update system state. Stop procedure looks similar, just in reverse order. First we stop the heater, wait 5 seconds to cool it down, close the valve, wait another 5 seconds, and stop circulation pump. To adjust the valve, we use some simple equation based on set point from control panel and current temperature in living room. Of course, it's far from what you would like to have in real life, but once again, it's not scientific guide on designing temperature regulators, so I keep things as simple as possible. After setting new valve position, we check if our system still needs to run. If conditions have changed in the meantime and radiator valve remains shut for some time, 5 seconds in this case, we probably don't want to run all the devices for nothing. We just stop the system, and if conditions change later on, it will get restarted automatically. Finally, we wire everything together within index.ts file. We assign callback to main switch that will start and stop the system on update. Assign on model change to model, on temperature change to both thermometer and control panel set point, and set initial state of our system. Done. Controller is ready. Let's see it in action. It's TypeScript this time, so I need to compile my project to JavaScript first. Now I can start it. Up and running. All necessary devices are online, so status is ready. Let's switch it on. Nothing happens as our set point is below temperature, so there is no need to start heating right now. Let's increase the set point. Status have changed to starting and pump switched on. Valve got adjusted. And heater got started. Great, temperature is rising, status changed to running, so far so good. Current temperature is way below set point, so valve is fully open, but we are getting closer. And valve position is reduced automatically to keep temperature as desired. Perfect, temperature stabilized approximately where we want it. Let's see what happens if I decrease the set point. Valve got shut, temperature is falling. It will take some time, so the system is shutting down as it's not needed at the moment. Heater is off, valve was shut down already. Finally, circulation pump shuts down and system status changed to ready. Temperature still falling. Getting close to set point. And system starts up as soon as temperature falls below. Cool, that's exactly how it was meant to work. Of course, real heating system would be much more complicated, but I just wanted to show you the principle of creating such logic with Stargate system. If you like to play with it yourself, you can download the entire smart home system from Node.js examples section on project page. Be invited to check other videos as well. If you like the video, please leave thumb up or a comment. It's nice to see any feedback from you. Thanks for watching and see you on other videos.